In this session, we will use WaveDynamix to generate traffic through an access point, and then we will use WaveAnalyze to take a look at the performance of the transmitter in passive mode of WaveAnalyze. This uses the RF testing capability that's in the Layer 1 cards, the RF 36014. So first we will go to WaveDynamix, and the connection process in WaveDynamix is somewhat similar to the Wave applications, but WaveDynamix is built to not be a turnkey test, but to rather give you the control to make one change at a time, take one step at a time. So it's more aimed towards diagnosing and troubleshooting problems on your access point. So let's walk through, and you'll notice that the first tab that comes up here is System, and we're going to work our way from System, Configure Clients. We'll skip over Agents at this point, and we'll go to Traffic, and we'll just get a simple flow up and running on WaveDynamix. First thing we're going to do is put in the chassis. I happen to know that the IP address of this chassis is 192.168.254.46. And we'll go over here and click Connect. Now you'll also notice that there is an action tab or action button over here. That gives you, if we select a particular port, it gives you a set of things that you can do with that port. Another way of getting to the same set of selections is to right click while hovering or having selected a port, or on other pages, client and traffic. So the right click is a shortcut that gets you to the actions as well. Okay, so the other thing that you notice that I have here is configured properties. So I have a tab over here to the right hand side that shows properties, and I also have events. So events will just be the status and information as the application is moving along. Any place where we need to be reporting information will come up in the events tab. So connecting clients, ARPing through, starting traffic, stopping traffic. It's just a place for you to get feedback on what is going on, and if something is not working correctly, this will be one of the first places you'll get an indication from the application of what's going wrong. Properties will change based on what you have selected, whether it's a client, traffic, or a card. So notice here, the card is selected. It gives us what information we know about the card at this point, what the statistics are coming from that card, which of course at this point is nothing. We've not done anything with the card. These same statistics are available also in reporting, and we'll get to that in a moment. So the first thing we need to do is to reserve the port. So I right clicked and I'm going to reserve the port. And notice that the port turns blue, so green means it's available, blue means it's reserved. On a Wi-Fi port, the next thing we do is we need to scan all of the channels so that the port becomes aware and the application becomes aware of what access points are available. Right, so we're going to scan all channels, and over here in events, we'd see began the scan, and it found an AP on channel 6, and it found another AP on channel 153. If we go back to properties, here we now notice that in the properties, visible access points have been added, and one in 2.4 and one in 5. This turns out to be the same AP that's just broadcasting on channel 6 and channel 153. And if we highlight, here's more information about that access point. Right, so we know what its SSID is, right? It's Netgear 5G. Here's its BSSID, and then any information we want to know about what's coming out in the beacon is here. So now the port is reserved, and we have populated the database of the application with the channels and access points that are seen on those channels. Now the next step will be to reserve an Ethernet port. We're going to do downstream traffic, so we're going to generate traffic that goes from the Ethernet port to the Wi-Fi port, so we can then use the RF 36014 to measure the quality of what the access point is transmitting. So now we've got the ports reserved, and at this point everything is static, right? So we've reserved the ports, no other activity is going on, the ports are just sitting there reserved and waiting for further instructions. Now there are other things that you could do here, and we'll come back in an advanced session on WaveDynamix and talk a little bit more about taking control of the port, doing packet captures and things of that nature. Next we'll go to clients, and we're going to need two clients. We're going to need a Wi-Fi client and an Ethernet client. So we'll name the first one Wi-Fi. We can choose its client type. We want it to be Wi-Fi. Now as we move across, if we at this point in time tell it what port we want that client on, now the application has the ability to start associating information known about that port with the client that we are calling Wi-Fi, right? So here we remember in an earlier step on system, we scanned that port. So now that port knows about a 2.4 gig and a 5 gig channel and the SSID and BSSIDs that are there. And so now the application can map the Wi-Fi client onto one of those. And we'll have to choose a channel under the client definition before the BSSID will get filled in. Notice here there's TX power. This will be the transmit power of our client. We'll just leave it at -6, but this can be dynamically changed while traffic is running. So this is a great place to come back and do something like a receiver sensitivity test. Count just means this is a client group. So how many of those clients do you want to have created? We'll do only one. The connection sequence, we can do some custom things in terms of modifying the connection sequence, and we're not going to do that at this moment. And the target state, once we get to the place where we are wanting to connect the client, we can tell it where we want it to go, if we want it to go all the way to an associated state or not, right? So we've created a Wi-Fi client. Now we need to define some things about that client. So if you remember in the Wave apps, once we had a client group defined, we'd have to describe what PHY rate to use, whether it's static IP addressing, those kinds of things. Okay, well, we need to do the same thing here. So obviously when you have that row selected, now you'd expect that the actions are that we could edit that client group. Okay, so let's go edit that client group. That opens up a widget for us where we can make some changes on the general page, but generally you want to go step by step by step and talk about the PHY connectivity, PHY definitions, and then go layer 2 and then layer 3. So let's start with the client definition. We want this to be an 802.11ac client. We would like it to be 80 megahertz. We'd like it to be MCS 9. We'd like it to be short guard interval. If we wanted to turn on the channel models, we could do that here. If we wanted to vary the amount of transmit power from this number by antenna, we could do that. If we wanted to introduce purposeful frame errors, we could do that here as well. We're going to enable aggregation. And these things we'll leave as default, but obviously you see client learning, power save, WMM could be turned on over here. Let's now keep working ourselves from the left to the right at layer 2 network. Here we can set up security. Happens that we are in open security, but here's where we will set up the radio band. So we do want 5 gigahertz. That'll default because we defined an AC client, but we saw on channel 153 an access point. Once we select channel 153 for this client group, the BSSID or the SSID shows up as being available because we had scanned that port earlier. So we'll choose that. We'll leave everything else default here. And on layer 3, let's make it a DHCP client. We'll let the client get its IP address from the router. It's a Netgear router that we're running here. We'll say OK. Now if I go here and either select Actions or right click, I can connect that client group. So now you'll notice it turns yellow, which says it's in the process of connecting. Then when it turns green, it has connected. So it changed to IP address acquired. That was the target state, that it needed to be connected and IP address acquired. So now this one client is connected to the access point and is just sitting there. It's awaiting further instructions. Let's now go and add an Ethernet. We'll call it ETH. An Ethernet client group, Ethernet. We tell it what port to be on, and we will right click, edit the client group. Now there's nothing that we really need to change here. We could, but here all we need to do is tell it to be a DHCP client or give it a static IP address. Now if I ask to connect that client group, it goes and gets connected. So at this point I have an Ethernet and a Wi-Fi port selected, reserved. I have created a Wi-Fi client on the Wi-Fi port and connected it up, and an Ethernet client on the Ethernet port and connected it up. Both have IP addresses. Now I'll go to traffic, because the next step is to add a flow, and I'll call that flow down. I need to tell it what it is and where it's coming from and where it's going to. So I could specify a specific client that's in a group, or I could use a wave agent here. But if I just leave it as client group and say, well, I want the Ethernet client group to be the source, I want the Wi-Fi client group to be the destination. Now in this case, I only have one client in that group, so everything stays simple. But you can see here that if I wanted to run 10 Wi-Fi clients to, or 10 Ethernet clients to 10 Wi-Fi clients, I could make the source be that Ethernet group and the destination be the Wi-Fi group, and the application will take care of mapping all of those things for me. Or if I want to create something that's more complex than that, I can choose individual clients out of a group, in which case if I said it was a client specifically, then it's going to ask, okay, which specific client are you wanting to use? So now I can create traffic flows that are specific either to a group or to an individual client. So I'm going to just stay here with client group. And there we go. Now I'm going to describe what frame rate I want. Well, let's give it a good load. So 70,000 packets a second. 15 18-byte frames. This ARP on means that the clients will ARP through the network under test before trying to run traffic, and whether I want to insert CRC errors or not. And we go back to our action button and say start to flow group. So if it does an ARP exchange, and then when it turns this nice shade of purple, that means traffic is running. So at this point, we have a steady state situation where we're running 70,000 packets per second from the Ethernet to the Wi-Fi, and it just sits there and will do that forever. So it's a very effective way to make some kind of a steady state situation. I can change the frame rate dynamically. Now, all I did is just changed the frame rate. Right, so it's all dynamic. I could go back here and change the TX power as well. So it's a nice way to just get a steady state situation and make deliberate changes. Now, obviously, we're at a place where we can't really see much what's going on. So let's open up reporting, go to measurements, and I'm just going to select basic traffic per port. This just then gives me the two ports, Wi-Fi port and Ethernet port, and here I can see I'm transmitting signature frames and I'm receiving signature frames. So 30,000 packets a second are being transmitted, 30,000 packets a second being received. I can see the FCS error rate as they're coming into the Wi-Fi card. So let's set this back up to our 70,000 packets a second. We notice here that when we attempt 70,000 packets a second, the number of frames transmitted tops out at about 39,000 packets a second. So we are already in a situation where we're exceeding the capability of this access point under test. So let's back it down here to 38,000 packets a second. That ought to allow both sides to match. The other thing I can do under reporting measurements is I can, there are several different choices I can make here, do custom port reporting, but a very useful one is this flow-based. Now I can choose a particular flow and I can either make a table of information about that flow, but a very useful thing is to make a chart. And at the very bottom here I have offered load and forwarding rate. And I'll select those, resize. So now I see at a glance I've got a red and a green, and they're actually just overlaid right on top of one another at this point. So let's increase this to 50,000 packets per second, and we'll notice that, okay, the offered load goes up to 600 megabits, but the forwarding rate stays down at 490 megabits. Right, we're offering 600 megabits and we're forwarding 470 megabits. So this gets us up and running where we can at least see what's happening on the traffic side. And we'll drop this back down to 38,000. So at a glance, we can see the traffic being offered, the traffic being received. We can have at a glance a view of the FCS error rate, and we can see that the FCS error rate is very low. So this is the first go round of getting traffic configured and up and running in order to make a wave analysis test. So this is WaveDynamix. And we're going to leave this running, and the next session will take us through taking this steady state situation of running downstream traffic, and now the next thing we'll do is open up WaveAnalyze and look at the quality of the RF signal coming from the access point.